Throughout the history of astronomy, the Hubble Space Telescope distinctly stands out for revolutionizing how scientists look and understand the universe. It continues to reform the general public's interest in space and is creating the reaction of uniting countries in space exploration and research. It has done this by constantly streaming images and data of all types of astronomical objects to Earth, which are then used by scientists, educators, and civilians everywhere. One scientist even goes to say, "The Hubble Space Telescope is perhaps the most significant scientific instrument ever created by humans." The images and data gleaned from the observations made by this unique observatory in Earth orbit have provided clues to some of the most fundamental questions in science. The reach of the Hubble has extended well beyond the realm of astronomy, with the result that Hubble has become an icon for science. However, the Hubble wouldn't exist if the telescope hadn't been created. In 1609, Galileo Galilei invented the first telescope, which used lenses. In 1668, Isaac Newton developed the reflecting telescope, which was more powerful and is the kind still used today.
Telescopes continually progressed, and so did astronomy, until in the 20th century, astronomers were looking to learn more about the Milky Way galaxy. Between the 1920s and 30s, Edwin P. Hubble found that not only were there more galaxies beyond the Milky Way, but that the universe was expanding. This brought astronomers to start searching for new ways for telescopes to see farther into the universe. In 1946, Lyman Spitzer wrote the report Astronomical Advantages of an Extraterrestrial Observatory. In it, he describes how a telescope could be launched into Earth orbit with a rocket, saying, "The chief contribution of such a radically new and more powerful instrument would be not to supplement our present ideas of the universe we live in, but rather to uncover new phenomena not yet imagined and perhaps profoundly change our basic concepts of space and time." He understood how it would have a major advantage over ground-based telescopes because it wouldn't have to face the distorting effects of the Earth's atmosphere. This novel idea was so ahead of its time that it wasn't until later that development of rockets for space exploration started.
In the 50s and 60s, the US and Russia were in a race to send the first rocket to the moon. This brought about the creation of the National Aeronautics and Space Administration, NASA, in 1958. These developments led to the start of the Space Shuttle program. NASA could now start on Spitzer's ideas and start producing a telescope that could be launched into Earth's orbit on a rocket. Planning for the Large Space Telescope started in the 1970s, and it involved the work of thousands of engineers, workers, and scientists in the US and the European Space Agency. A final design was made in 1978 following the Ritchie creation design named after George Willis Ritchie and Henry Grecian. The name was changed from the Large Space Telescope to the Hubble Space Telescope in memory of Edwin Hubble and his contributions to astronomy. The construction began and was set with a proposed launch in 1983, but the project was postponed by technical delays and budget problems with cuts from the U.S. government. It was postponed again by the Challenger disaster in 1986. When finally launched on April 24, 1990, in Cape Canaveral, Florida, scientists found that the main mirror had been ground incorrectly, significantly compromising the telescope's capabilities. The mirror was 2,200 nanometers too flat, and this caused the images from the Hubble to be blurry and unfocused. However, after a servicing mission in 1993, the telescope was restored to its intended quality. Astronauts were launched into space to add a lens to the flawed mirror that would make the images focused and clear. More service missions were launched to replace, update, and repair various parts and instruments of the telescope.
Although Hubble's images were blurry at first, once its mirror was fixed, The reaction was that the images were unparalleled by any ground-based telescope. This allowed Hubble to see farther into the universe than astronomers had ever seen. It would now produce images at amazing resolution in visible, near-ultraviolet, and near-infrared wavelengths. Two of its most important data collections are the deep field and the ultra-deep field. The ultra-deep field was the longest exposure ever taken of one specific region of the sky by a telescope. It focused on an incredibly minuscule portion of the sky and was a glimpse of over 10,000 galaxies, showing how they were at around 13 billion years ago. It looks so far into the universe that the light observed is still traveling and hasn't reached us yet, so it looks as it was billions of years ago.
Ground-based telescopes have to look up through the atmosphere, and the atmosphere is sort of like being at the bottom of a stream. You have the atmosphere moving above you. It causes distortion of starlight, which is very difficult to compensate for, and so you end up getting blurry images from the ground. So being above the atmosphere allows the Hubble to take images that are much sharper, have no effect of the atmosphere.
These groundbreaking images are just some reasons why Hubble is such a revolutionary and important instrument in astronomy. The observatory has recorded nearly 1 million images and spectra in about 110,000 trips around the Earth. Some additional discoveries and information that the Hubble has brought are finding the existence of black holes, more information on the life cycle of stars, formations of galaxies, nebulae, and planetary systems. Familiar objects viewed at Hubble's very high resolution often have shown unexpected aspects. Also, it has shown how quickly different types of galaxies formed after the Big Bang, and a very important discovery it has made is that the universe is accelerating in its expansion. This is contrary to the belief that it's slowing down because of mutual gravitational pull, and has led scientists to introduce the theory of dark energy.
One of the big mysteries is regarding dark energy and dark matter. The Hubble has helped investigate that, and one of the reasons we make telescopes like the Hubble and the James Webb is to make observations that lead to new questions
Hubble has imposed a reaction on more than just scientists, though. Its pictures have captured the admiration of the public, and the pictures, along with data collected by the Hubble, are used in education.
The Hubble Space Telescope has publicized the true miracle that the universe is, and created a crucial reaction in astronomy by providing answers to questions about the birth and even the fate of the universe, and has also raised new questions to hopefully be answered by the upcoming James Webb Space Telescope. The James Webb Space Telescope will be launched sometime in 2018 and will go beyond Hubble's capabilities. The JWST will observe in infrared waves opposed to visible light waves to better penetrate dust clouds, and will have a primary mirror that is 21 feet in diameter compared to the Hubble's mirror, which is 8 feet in diameter. This larger mirror will allow the JWST to see not only farther, but will resolve even sharper images.
The reaction that Hubble has made has revolutionized our interest and understanding of the universe, our place in the cosmos, aided science education, and has cleared the way for more advanced telescopes to come.